So I'm Levi Perigo. I'm full-time faculty in the TCP department, and my focus is on network engineering. So I like to tell my students, whether everyone knows it or not, these are some of the most important jobs in the world because nothing works without a network, right? You can't have interspace connectivity, you can't have wireless connectivity, nothing works without the network. So my focus and my research is on network engineering and specifically software-defined networking, which I'll talk a little bit about today. So in addition to my full-time faculty here at CU, I'm also a research associate for the Open Networking Foundation. So if you're not familiar with that, what we work on is if we had to do networking all over again, start from scratch, what would we do? Right? So it's all open source, it's Linux-based. It's pretty much now the new model, which is software-defined networking, is based on the computer server industry, right? You can modularize, you can take and pick and choose what you want. So that's how the networking world is moving. In addition to that, I'm a subject matter expert for the Research Council at MEF on their SDN NFV. And what we're working on there is we're creating a global API for the internet, so an application programmable interface, so that any internet service provider in the world can say, I want to connect from point A to point B, and it'll connect through multiple service providers by using one global API. So in addition to that, I'll tell you a little bit about software-defined security. So anything software-defined is the kind of new networking paradigm, software-defined networking. And what that is we're going to have a centralized controller or brain, right? So think of logically centralized but physically distributed. But we have that one brain that knows everything about the entire network, right? So think of that from a security perspective. No longer is it box by box decisions or box by box security. I have one brain that knows every single device in my network. So think about that from security, right? If something enters my network that's bad, I can block it not only there, but I can block it anywhere else in my network so that it never tries to attack from a different place. It can't manipulate itself. Okay, so a few of the things that we're doing is with SDN, right, we're using applications or software or programmability to manage and change our network. So one current one that we're working on is distributed denial of service. We can detect that and mitigate that. So with a larger internet service provider in Denver, we posted a honeypot. If you're familiar with that term, it's a public-facing server that allows access, and they think, oh, we're attacking this server. Well, we do it for two reasons. One, a large internet service provider, if their network is now kind of running on servers and software, what we can do is if we receive an attack, we can just spin up another virtualized version of that server, and then another one, and then another one, and another one. As far as the internet service provider is concerned, it's just like they're getting a lot of traffic to their website. They don't care. They just spin up another one. And their argument is, well, I have more compute power than anybody who can attack me, so I just spin up a new one, spin up a new one, and spin up a new one. Okay, so that's part of it, but what we're doing on the back end is we're capturing all this data so that we can see, hey, we have a public-facing device. What kind of attacks are we getting? Okay, and that leads to phase 2, where we use machine learning to prevent this in the future. Okay, so part 2 here is the intrusion detection and prevention. So with SDN, Snort is a popular security. We can have signatures that come in, and if you see this signature, take some action, right? So with SDN, we can program it to say, hey, anywhere in your network, if you see this security vulnerability, go ahead and take action A, B, or C. Okay, so we can do that right now, but what we're doing with phase 2 is we have all of this data, right? We have a public-facing web server. Anybody who attacks that, we're capturing all of that. So we can train our machine learning algorithm in a 3-phased approach. So for example, if you see a brute force password attack, well, if you see 5 in a minute, take one action. If you see 50 in a minute, take a different action. If you see 1,000 in a minute, take a third action, right? So similar to, if you're putting your hand towards a flame, right, the closer it gets, your brain says, all right, you need to start thinking about backing it off. Okay, that's really high. Okay, you're in big trouble, right? So we're doing that same thing with machine learning of once we can classify all these attacks, we can start to train our system and our network to say, this looks like an attack, make this change. This is even a bigger attack, make a bigger change. Or all systems are going to be down, redivert everything, change everything, add these security policies, block this. And if you see something like this again, the first time, don't provide the warning, just block it straight away. Right? That's how we're training our machine learning algorithm. But all of these things with software-defined networking, right? It doesn't matter anymore. It's not limited to physical boxes. It's cloud, it's data center, virtualization, traditional, space, terrestrial, right? If everything's software, right, it doesn't matter on physical boxes anymore because we can program it to do whatever we want. So I'm Levi Perigo. I have my contact on the first slide, but I'm super passionate about this. If you have any questions, please let me know. Thanks.